finally, we get to question 4, force electric in a box. Well, force electric in a box basically means we're going to have 4 charges arranged in a rectangular shape. We need to find the magnitude and direction of the net force on charge 3. So go ahead and click to begin your problem. Now, take a moment to write down where your charges are. I'm going to take a moment to write down where mine are, okay? And then we'll go ahead and get the problem going. Okay, so now that I figured out the charge, I'm going to go ahead and label these charges. So this is going to be Q1, which is negative 400 nanocoulombs. Okay, charge 3, which is the one we're trying to find the force on, that's positive 474 nanocoulombs. Charge 4, way over here, Q4, is negative, in my case, it's negative 553 nanocoulombs. And charge 2, down in here, in my case, is negative 383 nanocoulombs. Okay, so I got to find how the forces are interacting with charge 3. So I'm going to need this distance here, and that distance across the diagonal there. Okay, let's take a look at this distance first. We can see that this is 0.08 from here to here. So 0.8. And then from this side over here, we can see that's 1.6. So if I add that all up, I get 2.4. So 2.4 centimeters separates charge 1 and charge 3. Charge 2 and charge 3 seem to be separated by 1.4 centimeters up here. And then finally, to figure out this, I need to use Pythagorean theorem on those values to figure out the diagonal. So pause the video and figure out your diagonal across your rectangle arrangement. Okay, so for me, my distance across the rectangular arrangement is 2.78 centimeters. All right, now I'm going to figure out some angles, okay, with regards to the direction of force, okay? So for this one, we have charge 1, which is going to pull charge 3 to the left. So this would be F13. For me, charge 2 is going to pull charge 3 downward. So I'm going to call this F23. And then finally, you can see that charge 4 in the lower left-hand corner is going to pull the charge 3 down at this diagonal right here. Okay, so we need some angles to work with. Well, the angle for this charge here, F13, is going to be 180 degrees because it's pointing directly to the left. So F13, that's 180 degrees. For F23, that's pointing straight down. Well, straight down, as you can see, is 270 degrees. Now, this angle here, I got to figure that out. So it's going to be the arctan of 1.4 over 2.4. Which is about 30.3 degrees. Okay, now 30.3 plus 180. Okay, so if I add the 180, now we're looking at an angle of 210.3 degrees. Okay, so what we're going to do, we're going to do the same thing that we've been doing, okay? We're going to find the x and y components for all these, okay? Now, this is going to be pretty easy because this right here, F13, only has an x component. It doesn't have a y component because it's only pointing to the left. F23 only has a y component and not an x component because it's pointing down. F43 is the only one that's going to be pointing, going to have an x and y component. Okay, which we'll go ahead and use the 30.3 to be able to figure that out. Okay, so F13. F13 is pointing directly to the left. Okay, let's find it. It's going to be K Q1 Q3 over R squared. That is going to be K, that's 9 times 10 to the 9, times Q1. Now for me, that's 400 times 10 to the negative 9 times 3, which is 474 times 10 to the negative 9. Okay, and we're going to divide that by 0.024. This is in centimeters. Yep, it's in centimeters. So we're going to convert that to meters and then square it. Okay, so we have. Okay, so we have our values ready. I'm going to go ahead and pause the video and go ahead and find the electric force between charges 1 and charge 3. Okay, so for me, I get about 2.96 newtons of force. So what that means is in the x direction, this is going to be negative 2.96 newtons. That would be F13 in the x direction. F13 in the y direction is going to be 0 because, well, it's not pointing in the y direction. Okay, F23. Now, F23 is pointing straight down, which means it's only going to have a component. So F13 in the y direction is 0. F23 in the y direction can be found using Coulomb's law. So K Q2 Q3 over R squared, which is 9 times 10 to the 9, times, okay, I'm going to put in my values. You go ahead and put in yours. The distance between charge 2 and charge 3 is about 1.4 centimeters, so that's about 0.014 meters. And at this time, go ahead and pause the video and figure out your electric force between charges 2 and 3. Okay, so for me, I am getting 8.34 newtons of force. Okay, now F negative 2, 3 is going to be negative 8.34 newtons because of force it's going downward. Okay, and then F13 in the y direction 0. All right, now finally F43 is pointing down at an angle like this. So we need to find its magnitude, which is the hypotenuse. Then we need to find its vector components, which would be F43 in the x direction. And let me just scoot this over. And F43 in the y direction. Okay, so let's find F43. That's going to be K Q4 Q3 over R squared. That's going to be 9 times 10 to the 9 times Q4, which in my case is 553 times 10 to the negative 9, times Q3, 474 times 10 to the negative 9. Divided by the distance between charge 4 and charge 3 is 2.78 centimeters. So that would be 0.0278 meters. Okay, take a moment to pause the video and figure out your force between charges 4 and 3. All right, so for me, I'm getting about 3.05 newtons. So to get my components, I'm going to need to go 3.05 cosine of, and that angle was, if you remember, 30.3. That angle right there. Okay, and my value for F43x is going to be negative because it's pointing left. So 3.05 cosine 30.3 is negative 2.63 newtons. Okay, F43y is going to be 3.05 times the sine of 30.3, which is also going to be negative because it's pointing downward. Now for me, I'm getting 1.54 newtons. Okay, now finally in step 5, in order to find the net force on charge 3, we need to add up all the x components, add up all the y components to find Fx and Fy. So Fx is going to be F13x plus F23x plus F43 in the x direction. Okay, F13x is negative 2.96 plus F13, so F23, let me see. So this should have been 2, 3 in the x direction. Sorry, I kind of messed that up earlier. Is 0. Plus, and then F43 in the x direction is going to be negative 2.63. So I got to add those up. 2.96 plus 2.63. So we're looking at negative 5.59 newtons. Okay. F in the y direction is going to be F13 in the y direction plus F23 in the y direction plus F43 in the y direction. Okay, and just looking at each of the 3 problems, F13 in the y direction is 0, plus F23 in the y direction is negative 8.34, and F43 in the y direction was negative 1.54. Okay, and for me, that adds up to be 0.34 plus 1.54, 8.34 plus 9.88. Okay, so for me, I found my F in the X direction and Y direction. Okay, pause the video and make sure you can find your horizontal and vertical components of net force. Okay, now that you found that, to find the net force, we of course use Pythagorean theorem. So that's going to be my x component, which is going to be negative 5.59 squared plus negative 9.88 squared. Now for me, I'm getting about 11.4 newtons. Okay, now to find the angle, I need to use my arctan formula of my y component, 9.88, over my x component, 5.59. Okay, now keep in mind, it's 5.59 in the x direction and almost double that in the y direction. So you can see the net force ought to be pointing down this way in quadrant 3, and angle theta ought to be pointing that. So we're going to have to take our angle from 0. Remember, take it from 0 to get my theta. So we're going to go arctan of 9.88 divided by 5.59, and that's about 60.5. If we add that to 180, we get an angle of about 240.5 degrees. Okay, there you go. I was able to get that one correct. I hope you were able to get yours correct as well. I hope you found these video tutorials to be helpful. See you next time.